Okay, this is the notes that go with section 5.1, and we already know how to do part of these, but we're going to go ahead and work all of these together. I think we're going to stop like at example 6, and then we'll do the rest of them together in class. But we're going to go through these really quickly because these you already know how to do. Expand the logarithm, so division means subtraction, so natural log of 10 minus natural log of 9. Okay, this can be rewritten as 3x plus 2 to the 1/2. So I can rewrite that by bringing down my exponent as 1/2 natural log of 3x plus 2. This can be rewritten as natural log of 6 plus natural log of x minus natural log of 5. And this one, I'm going to rewrite this so we can kind of see what it says a little bit better. This is this times the cubed root of x squared plus 1. Okay, so first of all, I'm going to do the top. I can bring down my 2. So I have 2 natural log of x squared plus 3 minus, and it's minus, I'm going to put parentheses because it's more than one thing. Okay, so this x right here, I can just say natural log of x plus, because it's x times this, and this is actually x squared plus 1 to the 1/3 power, right? Because the cubed root is the same thing as 1/3. So I'm going to bring that 1/3 down. And I need a natural log in there. That goes right there. X squared plus 1. So now I'm going to kind of simplify this. 2 natural log of x squared plus 3. I'm going to distribute my negatives. So negative or minus natural log of x minus 1/3 natural log of x squared plus 1. And that's my answer. So we already kind of did that in our last worksheet. So let's look at example 2. In example 2, we're dealing with the number e, which you already wrote down in your notes. And remember, e is just an irrational number, kind of like pi. Pi is 3.14, e is 2.718, and keeps on going. Okay, and we've already talked about when dealing with natural log, the base is always e. When dealing with log, log, the base is always 10. So we want to find the following. These are calculator problems. So we're just going to stick this in our calculator. You have your natural log button on the left-hand side. Natural log of 2. 0.693. We'll always go 3 decimal places. Part B, the natural log of 32, when I plug that in, I get 3.466. Now here's the thing. What did you just find? What is the natural log of 2? We know it's a number, but what is it that stands for? Remember how our base is e for natural log? That means e to the 0.693 equals 2. That's what we just found. 0.693 is the exponent that goes above the e to give me this number. Same thing with this. Okay, e to the 3.466 gives me 32. So that's what we're finding when we're finding the natural log of a number. Okay, example 3. You already have this written down in your notes. So the derivative natural log of x is 1 over x. The derivative, or the derivative natural log of u, is 1 over u times the derivative u. Okay, and I'm not sure if your book has, they're just saying we can actually take out these absolute value bars because they're saying that u or x will always be greater than 0. So we've already done these. This is my u. So y prime would equal 1 over my u times the derivative of my u. So my 2's cancel, 1 over x. Part B, find the derivative of natural log of x squared plus 1. Here's my u. So it's 1 over my u times the derivative of my u, which is 2x. So I would just write that as 2x over x squared plus 1. Part C, and that's my answer for that one. Part C, I'm going to use the product rule. Here's my first term, here's my second term. So product rule says the first term times the derivative of the second, which is 1 over x, plus the second term times the derivative of the first. So when I simplify, x times 1 over x, my x's cancel, and I just get 1 plus the natural log of x. Part D, y equals natural log of x quantity cubed. This is the chain rule. Chain rule says bring down my exponent, keep the inside, subtract 1 from my exponent, times the derivative of the inside. Derivative of natural log of x is 1 over x. You can leave it like that, or you could write it as 3 over x natural log of x quantity squared. So all of that you pretty much already knew how to do because of the worksheet that you did yesterday or today in class. Example 4. Find the derivative of f of x equals natural log of x plus 1. So sometimes when we find the derivative, we want to use properties of logarithms before we find the derivative. This is the same thing as x plus 1 to the 1/2 power. And we know that using properties of logarithms, we can bring our exponents down in front of the logarithms. So I have 1/2 natural log of x plus 1. And now that becomes an easier problem to find the derivative of. So f prime of x equals, this is just a constant, so it's going to stay there. This is my u. So the derivative natural log of u is 1 over u times the derivative of my u, which is 1. 1 over 2 times the quantity x plus 1. Example 5. There's a typo in example 5. I'm going to rewrite the problem. Here's the problem. F of x equals natural log of x squared plus 1 quantity squared over the square root of 2x cubed minus 1. So I definitely want to use properties of logarithms to rewrite this first before I try to find the derivative. So I'm going to write it over here. F of x equals. First thing, I have this natural log of x. So natural log of x, it's multiplication, so I'm going to do plus. Now I'm going to do x squared plus 1, and this is being squared. So I can put my 2 out in front, x squared plus 1. So I've taken care of the top. It's division, so I know it's going to be minus. Remember, this can be written as to the 1/2 power. So I'm going to bring down my 1/2 natural log of 2x cubed minus 1. So that's why we practiced using the properties of logarithms so that I could rewrite it so I can find the derivative. So now I'm going to find the derivative. F prime of x equals. Derivative of natural log of x is 1 over x plus 2 times, here's my u, so the derivative of natural log of u is 1 over my u times the derivative of my u. Derivative of x squared plus 1 is 2x minus 1/2. Here's my u, so it's 1 over my u times the derivative of my u, 6x squared. So now I'm just going to simplify. F prime of x equals 1 over x plus 2 times 2, that gives me 4x over x squared plus 1 minus my 6 and my 2 will cancel. So that's going to be 3x squared over 2x cubed minus 1. Okay, and we are going to stop with example 5 and we'll do the rest of these examples together in class tomorrow. Have a good evening.